Hello everyone. Today I'll be explaining FPGA implementation using Vivado, and we have ZedBoard with us. So let me start by creating a project. Click Next. Give a project name. We are trying to do the interrupt program. Next. Again click Next. Select the board. We are using ZedBoard, Zinc Evaluation and Development Kit. Click Next. Finish. Now you can add sources. Add or create design sources. Click Next. Here you have to create a file. You can type the module name which you want to give in your program. Click OK. Finish. Here you can define all the inputs and outputs. We have more number of inputs here. You can type one by one. I've given all the inputs. Also we have one out. Change the direction as output. I'm just checking once again. Okay. Click OK. You can see your Verilog code here in the design sources. Click on that. You can complete the program. I've written the program. Save it. After saving, you can run simulation. Run behavioral simulation. So if there are no error, it will go to the simulation window. If there are some errors, you have to cross-check the error. So I think up to this step, everyone might be very familiar because you can do it in your Vivado. So after that, RTL analysis, synthesis, implementation, program and debug all comes for FPGA implementation. I'll tell it one by one. So before going to RTL analysis, let me input here. We have to check whether our program is working. I'm inputting values. INT1 I made 0. INT0 I made 0. INT1 I made 1. So I'll run the simulation. You can see here. Okay. So until simulation we have completed. Now we can go for RTL analysis. So let me close the simulation window. Okay. Now open the elaborated design. It will show a window here. The current elaboration setting allow you to perform input output planning. So click on OK. Here you can see the RTL schematic here. This is not the schematic obtained after synthesis. After synthesis, you'll get another schematic. So this is actually the gate level representation. You can see the diagram which you actually wanted to write the Verilog code. So that is obtained. Now click on Windows, select input output port and click on Scala port, flow ports. Sorry. So here you can see all the inputs here and output. Okay. So we have got all the inputs and output. So according to the FPGA pin available, we have to change the package pin, give the package pin and the IO standard with respect to the ZedBoard, which is available to us. So we have all the input here. We have one output out. So we have to mention the package pins with respect to our ZedBoard here while we are trying to implement with respect to FPGA. So for that, we have a ZedBoard detail given here. Here you have all the banks available with respect to ZedBoard and the pins. So you can see here user LED act as output. So these are the outputs which are available for our ZedBoard. And we have, again, you can see input as push button is there. Also DIP switches are here. We have 8 DIP switches and here 5 push buttons are here. These are bank 34 and 35. I think, yeah, 35. So you can see here. So also we have IO standards also here, whether it is LV, CMOS 18, 25, 33, so and so, and the output voltage also you can check here. So now I have to give the package pins here for all the inputs. So let me give that with respect to the ZedBoard available. Okay. So I have a user LED. Since we have one output, no, I'll take a T22. I'll input it here. Okay. So for out, I am giving T22. Okay. So corresponding bank will be automatically updated. Okay. So I'll give all the inputs now. So let me give, we have inputs INT0, INT1. Okay. I'll give for INT1. So let me see what all are the inputs. So I'll use the DIP switches. We have pin F22, G22, H22, F21, H19, H18, H17, M15. So I'll show you the FPGA ZedBoard also. So in that I'll mention all these, I'll show you all the package pin description and on the ZedBoard. So I'm going to input these here. So INT0, I'll give F22. It should not be in a particular order. You can give accordingly. INT1 I am giving F21. Okay. Make sure you select the correct package pin. That's it. Then EX0 I'll give G22. Okay. EX1 I'll give H19. Okay. Next TF1 I'll give TF1. Okay. H18. RI H17. TF0. 22. Okay. Now we have TI R18. Okay. Fine. So I already told you there are 8 DIP switches here. So that 8 I've already used. And some more options are here for push button. Push button also act as input. So I can use R16, P16, N15, R18, T8. Okay. So I'll be using that also. So ET1, M15, ET0, N15. Okay. Then we have ES, R16, and EA, P16. So you can see here, these I have given push button. So I've inputted all the package pins here, input as well as output. Now I have to change the IO standard. So let me see the IO standard with respect to the, you can see bang, corresponding bang is also updated here automatically. So you can select the IO standard here for bang 33, 34 and all. So you can see here for 34 it is LV CMOS 33. For 33 also it is that. For 35 also LV CMOS 33. So I have to change corresponding IO standard for everyone. It is 33 LV CMOS 33. So our VCC output also changes automatically. Just have to select. So So I've changed all the package pin and the IO standard here. Now let me save the constraints. You can give a file name, any name. Click OK. Okay. So once you save the constraints, you can see it here. Here. Now the constraints pin XTC. If you click that, you can see which all package pins you have used, what are the IO standards. You can cross verify whether you missed anything or something. Or you can check what all inputs and outputs you have given. You can see here. Okay. So this is with respect to RTL analysis. Now we can run the synthesis. Here you can see number of jobs. So you can give it as 12. Maybe it is in default of some other values also. So change it to 12. Okay. You can see here running synthesis design here. It is still running. Okay, once it is completed, you can see here synthesis successfully completed. Now you can open the synthesized design. Click OK. So do you want to close the elaborated design? You can give it as yes. Okay. So this is the device. Here I'll just zoom and show you. We have not done the place and route. So you can see here the configurable logic blocks and all CLBs will be here. Okay. You can see here CLB LM. So a lot of devices. We have not done the place and route. Once place and route is done, you can clearly view your design here. Now I'll show you the schematic. I told like after synthesis, you can clearly see the schematic. You can see here. Okay. So after place and route, this will be there in the device also. Now let me show you the project summary here. We have the table in which the resources utilization is shown here for LUT, lookup table and input output. So we have 13 input IO pins used. We have 12 input and 1 output here that is shown here. So device utilization is also here. You can check the project summary whenever you want. So this is the schematic obtained. Okay, now we can go for run implementation. Then click on OK. We can see here initializing design. So if you want to see the design runs, you can check here what all we are actually doing the place and route here. So you can see here running optimal design here. Running route design. So place, route, everything will happen while we run implementation. So running route design complete it is shown. So implementation is successfully completed. Now open implemented design, click on OK. Then do you want to close the synthesized design? Yes. Now I told you here you can see a blue color. So we have done the place and route. Before I showed the device without place and route. Now you can see we have implemented the place and route. You can view it here. So let me zoom it now. You can see here wiring and all. You click on that. Okay. You can see here. Okay. On the place and route. If you want to see the wires, click here. Okay. So place and route is completed. Now click on the project summary if you want to see the power requirement and all. So already table we have checked LUT utilization. Now for on chip you can see the dynamic and static power utilized by our input output and logic. You can check all these things. Okay. So we have already completed RTL analysis, synthesis, and implementation. Now we have the program and debug session. So before trying to implement it in the FPGA, we have to generate the bitstream. Click on OK. I have already connected the FPGA using the USB cable here. I'll show you the FPGA board in another video. So you can see here running right bitstream still going on. Okay, so bitstream generation is successfully completed. Now you have to open the hardware manager. Click OK. Click on open target, open new target. Click on next. Again, click on next. If you don't connect the FPGA board, it won't show the local server. Once you connect it, otherwise it will be showing error. So once you connected it, you can select the device, hardware device here, XC7 to Z020. Click on next. Finish. Okay. So it is showing here XC7, it is not programmed. Can program device here. Then click on program. It will show programming the device. Okay. So now I'll show you the FPGA board. Once we finish this, FPGA will indicate a blue light there. It is programmed successfully. And if you remove your FPGA kit by any means, like if the connection is lost or something, it will show an error here, error warning. I'll show you that. Okay, so this step, up to this step is the FPGA implementation. Now we have to check the inputs and check whether our corresponding LED is blinking according to the enable input and all other interrupt inputs which we gave. So we can check that those conditions on the FPGA board. Okay, so these are the steps. I'll just give an overview. So we have done the simulation. Till now you might be doing only simulation part. So after that we go for RTL analysis and we see the schematic, gate level schematic. And in synthesis we convert the RTL into the gate level netlist. And here also we view the schematic. And in implementation we did the place and route. And we saw the place and route with respect to the device. And we saw the program summary of LUT utilization and other on-chip static and dynamic power requirement. Now, program and debug section include the generation of bitstream. Once you generate the bitstream, you can actually program your code to the corresponding FPGA device and check whether your code is working correctly with respect to the ZedBoard. So we can input the, or you can give all the inputs to the ZedBoard and check the corresponding output. Okay, so that's it.